Okay, so in the problem I explained in the email, we have two velocities. We have a velocity of 8.94 meters per second along the x-axis and a velocity of 7.15 meters per second. This is our second velocity. And we know this whole thing happens in 120 seconds. So, velocity 1 is pretty straightforward, so we're just going to go ahead and write down that the v1 equals 8.94 meters per second. Now velocity 2 is a little bit different, a little bit more complicated because it's not along a straight line on the x-axis. It's actually got an x and a y component. So we're just going to write down the v1 equals 7.15 times the cosine of 15 degrees to give us this x component right here, plus 7.5 times the sine of 15 degrees to give us this y component. And that's what we have written down right here. So let's just go ahead and solve to figure out what this equals, what the x component equals, and what the y component equals. So we end up with 6.91 x hat plus 1.85 y hat. Okay, now we know that the change in velocity for the x is going to equal the velocity of the final velocity of x minus the initial velocity of x. So let's just go ahead and write that down. So this is our x, and this is our first x. This is our final velocity, excuse me, of the x. And this is our initial. So we can go ahead and write that 6.91 minus 8.94 meters per second equals negative 2.03 meters per second. Now we know the y is the same thing. The change in the velocity of y is going to be the final velocity of y minus the initial velocity of y. So we have right here that the change in the velocity of y equals 1.85 y minus, and there's no initial velocity because it starts off just with the x along the x-axis, so it's going to be 0 equals 1.85 meters per second. Now, to find the average velocity of these two things, we're just going to go ahead and we're going to do a little bit of Pythagorean theorem. We're going to add them together while squaring both and then taking the square root of that. So we're going to have the negative 2.03 meters per second squared, which is our x, plus 1.85 meters per second squared, which are y, over the square root. And we end up with change in velocity equals 2.75 meters per second. Now we're not done because we also need the direction that the velocity changes. So we know that we have this x hat and this y right here, these two components. So solving for these two, the angle is what's going to give us the change in the velocity, the angle of the velocity. So we know that the tan is the opposite over the adjacent. So we're going to go ahead and put the tan of the opposite, which is this y. So the tan of 1.85 over the adjacent, which is the x, over 2.03 meters per second equals 42.34 degrees. And now this is our velocity. We have 2.75 meters per second, which is the change of velocity, and then the 42.4, which is the change in direction. Now, just to find the acceleration, we know that the acceleration equals the change in velocity over the change in time, and that's what the average velocity is. So we can just go ahead and plug in that the average velocity equals the change in velocity, which is this 2.75, over the change in time, which we said before was this 120 seconds. So the average velocity equals that over the 120 seconds, which ends up equaling 0.0229 meters per second squared. And that's how you do that problem.